everyone, welcome back to my channel. This is Rishabh and I am going to read and only read for you all guys almost all the chapters of 9th ICSE. So let's begin. So today let's continue the chapter Motion in One Dimension, Part 2. Displacement. The shortest distance from the initial to the final position of the body is the magnitude of the displacement, and its direction is from the initial position to the final position. It is a vector quantity. It is represented by the symbol S. Unit. The SI unit of displacement is meter and CGS unit is centimeter. Representation of displacement. The displacement, being a vector, is represented by a straight line with an arrow using a convenient scale. The tip of the arrow on the straight line represents the direction of the displacement, while the length of the straight line on proper scale represents its magnitude. Distinction between distance and displacement. The magnitude of a displacement is either equal to or less than the distance. If motion is along a fixed direction, the magnitude of a displacement is equal to that of distance. But if motion is along a curve or any zigzag path, the magnitude of displacement is always less than that of distance. The magnitude of a displacement can never be greater than the distance travelled by the body. Examples. In figure 2.0, the body moves from A to B along a curved path. The distance travelled by the body is equal to the length of the curved path AB, but the displacement of the body is along the straight line AB, shown by the dotted arrow. Obviously, the magnitude of a displacement is less than the distance. In figure 2.4, a boy travels 4 km towards east and then 3 km towards north. The total distance travelled by the boy is 4 km plus 3 km, which equals 7 km. But the displacement of a boy is 5 km in the direction due to from north from west. Thus, the magnitude of a displacement is represented by the length of the straight line between the final and initial positions. The distance is the length of path travelled by the body, so it is always positive. But displacement is the shortest length in direction from initial position to the final position, so it can be positive or negative depending on its direction. The displacement can be zero even if the distance is not zero. If a body after travelling comes back to its starting point, the displacement is zero, but the distance travelled is not zero. Distinction between distance and displacement. Distance, it is the length of a path traversed by the object in a certain time. Displacement, it is the distance travelled by the object in a specified direction in a certain time. Shortest distance between the final and initial position. It is a distance, it is a scalar quantity, that is, it has only magnitude. Displacement, it is a vector quantity. It has both the magnitude and direction. Distance, it depends on the path followed by the object. Displacement, it does not depend on the path followed by the object. Distance, it is always positive. Displacement, it can be positive or negative depending on its direction. Distance, it can be more than or equal to the magnitude of displacement. Displacement, its magnitude can be less than or equal to the distance but can never be greater than the distance. Distance, it may not be zero even if displacement is zero, but it cannot be zero if displacement is not zero. It is zero if distance is zero, but it can be zero even if distance is not zero. Examples. When a body is thrown vertically upwards from a point A on the ground, after some time it comes back to the same point A. Then the displacement of the body is zero, but the distance travelled by the body is not zero. It is 2h if h is the maximum height attained by the body. A body moving in a circular path, when reaches its original position after 1 second, then the displacement at one end of one round is zero, but the distance travelled by it is equal to the circumference of the circular path. Speed and velocity. For a moving body, speed is the quantity by which we know how fast the body is moving, while velocity is the quantity by which we know how fast the body is moving in a certain direction. By speed, we do not know in which direction the body is moving. Speed. The speed of a body is the rate of change of distance with time. Numerically, it is the distance travelled by the body in 1 second. It is a scalar quantity. It is generally represented by letter u or v. If a body travels a distance s in same time, then its speed is speed equals distance speed upon time. Since SI unit of distance is meter and of time is seconds, so the SI unit of speed is meter per second and its CGS unit is centimeter per second. Uniform speed. A body said to be moving with a uniform speed if it covers equal distances in equal intervals of time throughout its motion. Examples. The motion of a ball on a frictionless plane surface is with uniform speed. Knowing the uniform speed of a ball, we can calculate the distance moved by the body in a certain interval of time. If a body moves with a uniform speed, the distance travelled by it in time t is given as speed is equal to Vt. Non-uniform speed or variable speed. A body said to be moving with non-uniform or variable speed if it covers unequal distances in equal interval of time. Examples. The motion of a ball on a rough surface, the motion of a car in a crowded street, the motion of a vehicle leaving or approaching a destination, etc. are with non-uniform speed. In case of bodies moving with non-uniform speed, we specify their instantaneous speed and average speed. Instantaneous speed. When the speed of a body keeps on changing, its speed at any instant is measured by finding the ratio of the distance travelled in very short time interval to the time interval. This speed is called the instantaneous speed. The speedometer of a vehicle measures the instantaneous speed. Average speed, the ratio of the total distance travelled by the body to the total time of journey, is called its average speed. In case of a body moving with uniform speed, the instantaneous speed and the average speeds are equal. Velocity. The velocity of a body is the distance travelled per second by the body in a specified direction. Thus, the rate of change of displacement of a body with time is called the velocity. It is numerically equal to the displacement of a body in 1 second. So that's it for today, guys. Don't forget to subscribe to my channel. We'll continue the ahead of the chapter in part 3. Thank you.